Alright guys, in today's video we are going to use inequalities in a triangle to solve problems. Alright, in example 1 I was planning on having you guys do this on your own, but we decided that we would like to do this with you. So it says mark the largest angle, longest side. It also says to mark the smallest angle and the shortest side of the triangle shown at the right. And what do you notice? Okay. So the first thing, you don't have any vertices labeled or any sides labeled, so the first thing I would like to do is label all of my vertices, A, B, and C, just to give us a reference point. Okay, so if we eyeball the lengths of the sides of the triangle, I would probably say that this angle, B, is the largest angle, and then the longest side would probably be AC. So that would be the longest side, excuse me. Alright, so we got the largest angle, longest side. What's the smallest angle? I think, well, we have a competition between A and basic angle C. Angle C definitely looks more narrow, or more acute, I would say, than angle C, so I'm going to say angle C. And then the shortest side, if we were to compare AB and BC, AB would take the cake. So then the smallest angle would be angle C, and then the smallest side, or the shortest side, would be AB. What do you notice? Largest angle, longest side, smallest angle, shortest side. Well, if you look at the largest angle, the longest side is across from it, or opposite of it. And the smallest angle? Well, the shortest side is directly across from that. So the longest side and the largest and the largest angle are opposite of each other, and the shortest side and the smallest angle are also opposite of each other. Alright, now we have the side angle comparison. And if one side of a triangle is longer than the other side, then the angle opposite. Alright, so we had a typo, so we're going to cross off with the bell. Cross off side. If one side of a triangle is longer than the other side, then the angle opposite is larger than the angle opposite the shorter side. So if you look at it, the longer side in Exhibit A is AB. Okay? So then the shorter side, if we're comparing AB and BC, where 5 is the shorter side compared to 8, it's saying that the angle opposite of AB will be larger than the angle opposite of BC, just based on the side lengths comparison. Okay? So then AB is greater than BC, so then therefore we can say the measurement of angle C is greater than the measurement of angle A. Okay, using the converse of that, if we are just given in Exhibit B the angle measurements, so if we look at angle A, that's 50 degrees, and angle C, which is 30, so since angle A is greater than the measurement of angle C, we can conclude that BC is greater than AB. Alright, in example 2, we're going to have to use the side angle comparison. It says a long-tailed boat leaves a dock and travels 2,500 feet to a cave, then 5,000 feet to a beach, and then 6,000 feet back to the dock, as shown below. Well, we don't have anything shown because we're going to draw it out. So we have a long-tailed boat, and we are traveling to a cave. It's really fast travel right there. And it takes us, or it's about 2,500 feet away from our starting point. So that's going to be how long that travel was. Okay. From the cave, we went to a beach, and that was 5,000 feet. So that length from the cave to the beach is 5,200 feet, or 5,000 feet, excuse me. Let's just fix that really quick. 5,000 feet. And then finally, from the beach, we're traveling 6,000 feet back to the dock. And there's our dock. That's 6,000 feet. Alright, it says one of the angles of the path is 55 feet and the other is about 24. What is the angle made at the cave? So we want to figure out what this angle is specifically going from the dock to the cave to the beach, so this specific angle. Well, we know that all angles, interior angles, in a triangle will add up to 180 degrees. Okay? We're given one of the angles at the paths to be 55 and one of them to be 24. We don't know which one it is, but we just know that those are the two angles made either at the beach or at the dock. So then if I take 55 and add that to 24 and then plus my mystery angle at the cave, that should give me 180 degrees total. Okay, so if I simplify, 79 plus x equals 180, and then I subtract 79 from both sides, the missing angle is 101 degrees. So then, using the side angle comparison, of the three sides we have 5,000, 2,500, and then 6,000. The smallest angle, 24, well, should be across from the smallest side, which is 2,500. Excuse the bell there. And that is about 24 degrees. So then the 55 degree angle should be across from the next largest side, or the middle side, I suppose, which is 5,000, which is 55 degrees. And the largest angle, which is the remaining angle, which is 101, should fall or should be across or opposite of the side that is the largest. So then our angle made at the cave is 101 degrees. Alright, the triangle inequality theorem. The sum of the lengths of any two sides of a triangle. So you pick the two sides, that should be greater than the length of the third side. So if we take AB, which is right here, and we add that to BC, that should always be greater, that measurement should be greater than the last side, AC or CA. Okay, so the different combinations, we have AC, which is the longer side here, plus BC, that needs to be greater than the third remaining side if you add them together. And then finally, AB and AC will be bigger than the third remaining side, BC. Alright, the last example, it says find the possible side length. So if we have a triangle, if it has one side to be 14, the other to be 10, describe the possible lengths of the third side. So there's not an exact answer to figure out what the third side is, but we have to figure out what the range is, because it's got to fall between this number and that number, and I'll show you what that means. So if we have our triangle, one of the sides has to be 14 and the other has to be 10. I just picked two arbitrary sides. It could have been this one, but I just selected 14 and 10 to be on those specific sides. Alright, so then based on the last theorem, if we were to add any two sides of a triangle, that should always be greater, or the sum should be greater than the third side. Okay, so then 14 plus 10 has to be greater than the third remaining side, x. So if I add those together, 24, sorry, it's going really fast. 24 is greater than x, so I flipped it over. X has to be less than 24. So whatever the value of that third side is, it's got to be less than the value of 24. That's one of the combinations. So another combination we could have gone with was 10 plus x is greater than 14. So that's these two sides added together. Well, that sum has to be greater than that third side, 14. So if I subtract 10 from both sides, x needs to be greater than 4. So we have our value, the third side, needs to be either less than 24, and also greater than 4. Well, we have one more combination just to check out, which is 14, our one side, plus the missing side has to be greater than 10. Well, if I solve the inequality, subtract 14 from both sides, x has to be greater than negative 4, which makes sense because we've already said that x has to be greater than positive 4. So we don't even have to consider x is greater than negative 4. Our range has to fall between the 24 and between 24 and 4. So the third side must be greater than 4, but it has to be less than 24. So those are the possible values. We can have 5, we can have 20, we can have 22, we can have 15. As long as that third side's value is between 4 and 24, the triangle should work. Alright guys, that is all. Good job, and we'll see you on the Menjay.